Okay, so AI like ChatGPT has just exploded onto the scene, right? And it's raising this massive question, especially in education. Is this thing a revolutionary math tutor, or is it just a fancy calculator that's really, really good at sounding confident, even when it's wrong? That's what we're diving into today, the big promise of AI in the math lab versus what's actually happening on the ground.
Yeah, this is really the big question, isn't it? Can these large language models, can they really get the logic, the context, the creativity that math problem solving actually requires? Let's unpack that.
So here's how we're going to tackle this. First, we'll look at where AI even fits in the history of math tools. Then we'll check out a really cool kind of ideal blueprint for using it, something called the ILAC framework. After that, it's time for a reality check. We'll see what happened when ChatGPT was put to the test. We'll look at the frankly surprising results, and then we'll try to figure out what it all means for AI's role in the classroom right now. All right, first up, AI in the math lab. And even though this feels so brand new, it's really just the next step in a long, long line of tech we've used to help us crunch numbers and figure things out. I mean, just think about it. Back in the 70s, you had handheld calculators, and that was a complete game changer. Then the 90s roll around, and we get these powerful computer algebra systems, we call them CAS, that could handle some really complex stuff. And now, here we are in the 2020s with large language models, or LLMs, like ChatGPT that can talk to you about math in plain English. It's a pretty clear line of evolution, but, every single step brings its own set of cool new possibilities and brand new challenges. Okay, so we've got these incredibly powerful new tools. The big question is, what's the best way to actually use them? Well, let's start with the optimistic blueprint. Some researchers have put together a new framework just for this, and it's called ILAC. So what's ILAC? Well, it stands for Integrate LLMs Alongside CAS. The whole idea is to build this really smart, structured workflow where students aren't just relying on one thing. Instead, they combine the strengths of an AI chatbot with the power of traditional math software. The goal, to get the absolute best of both worlds. And the strategy is pretty brilliant, actually. You use the LLM, your ChatGPT, for what it's good at. The conversational stuff, brainstorming, exploring different ways to think about a problem, outlining steps just like you're talking to someone. Then, you turn to a CAS for what it's best at: pure, precise, 100% accurate calculations. It's kind of like having a creative partner to bounce ideas off of who just happens to have a supercomputer in their back pocket. The whole ILAC workflow is laid out in 6 stages. It basically walks a student through the entire process. You start with just understanding the problem, then you use the LLM to explore concepts and outline a plan. The LLM can even help you get the right commands for the CAS. Then you run the actual computation, and you end with what might be the most important part of all: reflecting on what you just did. It's a really smart, thoughtful way to approach learning. But look, a great idea on paper is one thing. What happens in the real world is often something else entirely. So, how good is today's AI at the kinds of things a framework like ILAC needs it to be? Yet it's time for a reality check. And that's exactly what a recent study did. Researchers took different versions of ChatGPT and basically threw a bunch of mathematical modeling problems at them. And these aren't your neat and tidy textbook problems. These are the messy, real-world kind, where you first have to figure out how to even turn the situation into a math problem before you can start solving it. So they set up tasks with different levels of difficulty. You had the rubber ball problem, which was pretty simple. All the data was right there. Then there was the refueling problem, which was a bit trickier. The AI had to make some reasonable guesses, like how much fuel a car uses. And then you had the water supply problem, which was super complex. It required the AI to make a whole bunch of assumptions about things like how big cars are and how much space is between them in a traffic jam. So, how did it do? Well, this is where that optimistic dream of a perfect AI tutor hits a bit of a snag. The difference between the AI versions was, wow, it was huge. GPT 3.5, that's the free one most people use, it really struggled. A lot. We're talking flawed logic and just straight up wrong answers, even on the easy problems. Now, GPT-4 was definitely better. It could handle the simple tasks just fine, but as soon as you gave it something complex, its solutions were often kind of shallow and just missed the bigger picture. And this quote from the study really nails it. The real problem isn't the math itself. It's about comprehending the nuances. The AI just has a hard time getting a feel for the messy, unspoken context that comes with real-world problems. And when you look at the data, the trend is crystal clear. The AI is great with simple, straightforward problems where everything is spelled out. But the moment you introduce a little bit of ambiguity or some missing information, its success rate just takes a nosedive. And that, right there, is the biggest challenge for AI in real-world math. Okay, to make this really concrete, let's zoom in on that super complex water supply problem. Remember the question? How long would it take to get water to every single car stuck in a 20-kilometer traffic jam? I mean, just thinking about it, you know you're going to have to make a ton of real-world guesses. So GPT 3.5's answer was, honestly, a complete failure of logic. It was almost funny. In the problem description, there was a little bit of story, some flavor text that mentioned someone had been stuck for 6 hours. Well, the AI saw that number, latched onto it, and completely missed that it was just background info. It then used 6 hours in its final calculation. It literally couldn't tell the difference between the story and the data. All right, so GPT-4 was way, way better. It actually understood that it needed to make some assumptions, like the average length of a car, to figure out how many cars were there in the first place. That's a massive improvement. But, and this is a big but, it made a huge oversimplification. It did all its math assuming the traffic jam was only in a single lane. I mean, when was the last time you saw a 20-kilometer traffic jam on a major highway that was only one lane wide? It just missed that critical piece of real-world common sense. So what's the bottom line here? Let's take that dream of the ILAC framework and put it side by side with the pretty sobering reality of these tests. It seems pretty clear that what we have is an incredibly powerful new tool, but it's not quite the hands-off perfect tutor we were maybe hoping for. So here's what you really need to remember. First, AI is awesome at simple, well-defined math tasks. But second, it really struggles with the gray areas, the ambiguity and context of messy real-world problems. And that means, and this is so important, that human oversight, our critical thinking, is absolutely essential. The dream is amazing, but the tool just isn't there yet. Look, what this all means is that a framework like ILAC is still a fantastic goal. It's pointing us in the right direction. But this study is a huge dose of reality. It tells us that right now, we have to be realistic about the tools we have. The student can't just sit back and let the AI do the work. They have to be the pilot, the director, who's in charge of these powerful but definitely flawed instruments. And all of this leaves us with a really big, fascinating question for the future. Will AI ever actually learn to think like a mathematician? To handle ambiguity, to make those creative leaps, to really understand the deep context? Or is it always going to be just a very, very powerful calculator with a great vocabulary? Honestly, the answer to that question is probably going to shape the future of how we all learn.